Hello everyone, let's look at a rangoli here. 2 dots, 3 dots. Not that rangolis are always made with the help of dots, but most of the times these dots are used to make rangolis, designs. See, this was a very simple rangoli. Now, let's make a slightly bigger one. I'm just including 4 more dots plus 5. So what was a total number of dots we included in the previous rangoli? It was just 1 plus 2 plus 3, which were 6 dots. And now I've increased 9 more dots. So just this time we are using 15 dots, which is 1 plus 2 plus 3 plus 4 plus 5. So let's see, 15 dots, slightly bigger rangoli. Yeah, excuse me for these lines. Maybe with the rangoli powder it will look better. And now this one, so connected. See, little slightly bigger one, a better design. Now a person wants to make a very huge rangoli. Very huge rangoli. Say now this is 5 lines of 15 dots, isn't it? The one which we made. Suppose he wants to make 25 lines, or what if he wants to make 100 lines. So let's say n number of lines, and he decides to place one flower each on each dot. He decides to place flowers. How many flowers in advance should he buy so that he has to make a huge rangoli for a special occasion with n number of lines? I'm just saying n can represent 100 or 200 or whatever the person decides to make. So what ultimately we are going to do now is we are going to find the sum of finite natural numbers. Natural numbers. The word here finite, of course, only when it is finite we are going to find the sum, and we can find the sum if it is finite. So what we are ultimately trying to do is find the sum of 1 plus 2 plus 3 plus 4 so on till n, because for n number of lines, for 5 number of lines we need 15 dots like this. So for n number of lines we need these many dots. So finding sum of finite natural numbers. Let's assume that this is equal to x. Once again the assumption is made that it is equal to x. It is equal to another number x because it is finite. So let me slightly remodify this for the purpose of adding. It starts with 1 plus 2 plus 3 and so on. And let me rewrite the last 3 numbers here. Can I write it as n minus 2 plus n minus 1 plus n, isn't it? So adding maybe 1 and n first. You get 1 plus n. Now let's add the second term 2 and the last but one term n minus 1. We get 2 plus n minus 1. Similarly, 3 plus n minus 2. And so on. It doesn't end here because we are going to keep adding terms like this. So what does this give us? The first term is of course 1 plus n. Second term 2 plus n minus 1. 2 minus 1 is also plus 1. So one more 1 plus n. Let me write it as n plus 1. Addition is commutative. It's 1 plus n and n plus 1 are the same. And 3 plus n minus 2 also gives us 1, n plus 1 as 3 minus 2, 1, and so on. So how many n's are we going to have? You remember that the terms are being halved. It's going to be exactly half of the previous number of terms because you're adding 2 terms each time. There are n number of terms. There are n number of terms to be added, and each time we are adding two terms, isn't it? So we would have exactly here n by 2 terms, but mind you, only if it is even. Only if n is even, we can write it as n by 2. What will happen if n is odd? This n by 2 is not going to hold, isn't it? So I cannot say this is n by 2 numbers of n plus 1. I can't say it because we do not know whether n is even or n is odd. So let us make it even for that purpose. How do we make it even? Just add x plus x 2 times, twice. So we'll be damn sure that this is going to be even. Even the n here will be made even. Even if it is odd, if it is added 2 times, it's going to be even. So what is x plus x? Now rewriting again. I have once this sum 1 plus 2 plus 3 and so on till n minus 2 plus n minus 1 plus n, but I have to add it again because we are making an x plus x. We are going to add it twice, but for the second time, let me add it in the reverse order. Reason, number one, addition is commutative. Number two, anyway, we are going to add it like this, 1 plus n. So let me rewrite the n here, n, and the second term plus n minus 1, and the third term plus n minus 2, plus so on. I am saying first term, second term, and third term because I am writing it in the reverse order. This would end with 3 plus 2 plus 1. So let us add now. We are adding everything. We are adding everything. So let us add now. Now I'll just show you the first term and the last, not the last term of course. We are adding 1 plus n. The first term of the first sum x and the first term of this, the same sum of finite natural numbers written in the reverse order. So this will give us n plus 1, n plus 1. And now let's add 2 and n minus 1, right? 2 plus n minus 1, which will also give us, as we saw before, n plus 1, isn't it? And let us add the third term now. The third term is 3 plus n minus 2. Once again, it is the third term of the once written in the correct order, second time written in the reverse order. And whatever it is, 3 plus n minus 2 is also n plus 1. So how many terms are we going to get like this? How many terms are we going to get like this? We are going to get, see, the last term. Let me write only the last term here. That is also n plus 1. So how many n plus 1s are we having? We'll have, first is n terms, second also n terms. So we would have, yes, 2n terms, right? 2n plus 1s. Is it so? Would we have 2n plus 1s? No. We would have n plus 1s. n plus 1. Why n plus 1? Because 1 plus n, 2 plus n minus 1, 3 plus n minus 2. So every time we are adding two terms together, so we will have n terms now. So the whole thing would be equal to n times n plus 1. What is n times n plus 1? 2x. 2x is equal to n times n plus 1, and x stands for the sum of finite natural numbers. So x is equal to, dividing by 2 on both sides, n by 2 into n plus 1. So this is, whether you represent it as x or s, sum of finite natural numbers Sn, this is going to be your answer. So this n by 2 into n plus 1 is the sum of all finite natural numbers. I hope you understood. In case any doubts you have, just try to add this step by step and everything will be very clear to you. Thank you.